Hi everyone, welcome to GPSTEC403. You know, it's interesting, we all just came from Andy Jassy's keynote. We listened to it, many of us were here in the overflow rooms, and it's really interesting because as AWS, we're evolving and innovating and iterating very quickly, and we're building a large portfolio of products and services for our customers. And obsessing over customers can often become challenging when you start to deliver a large portfolio of products in which you need to deliver these products in a repeatable and reusable and repurposable manner. And today, the goal of today's session is to talk a little bit about what it means to build a control plane on top of our platform for a solution provider to deliver a large portfolio of products, or even maybe one, but in a repeatable and reusable manner. Just to introduce myself, my name is Judah Bernstein. I'm a Partner Solutions Architect here at AWS, and I focus on software as a service here. It's interesting because I work as part of a team called the SaaS Factory. The SaaS Factory is a team that assists hundreds of ISVs yearly with building their platform or software as a service solutions on top of AWS. And what's interesting is today, I'll describe to you what a control plane could be, what the value proposition is, and I'll demonstrate a reference architecture that I've built that may just showcase some of the design considerations and approaches that you would want to incorporate in your designs. So to start kind of kicking things off, the first question I want to ask each of you is, if you want to build the next great solution delivered as a service on AWS, that's a platform or software, or for that matter, any number of services that are delivered in a repeatable way, there's a number of kind of components that you need to think about. And ultimately, what we want to start by doing is talking about what a control plane may be. And a control plane could be defined in a wide vast of arrays, but there are three core ideas that I think are very relevant. It's a massively, horizontally scalable platform which allows you to distribute services widely, and one that allows you to schedule these services potentially in global or regional deployments, to maintain and distribute these workloads for customers across a wide network topology. A topology that allows you to deliver things potentially in multiple AWS accounts, in multiple regions, multiple VPCs, based on the tenant profile. It could be a multi or a single tenant customer and their workload. And why it's the interesting thing is, why? Why build a control plane? And I want to start by talking about some of the things that we hear from customers. Because as the SaaS Factory team, we work with ISVs, independent software vendors. These are technology companies that integrate or build SaaS solutions on AWS. But ultimately, these providers, similar to AWS, they work backwards from their customers. And their customers are telling them that they want potentially to choose or select a product that works for their requirements. So deploy that product rapidly. And it's interesting is, we have multiple channels for provisioning in AWS. We have the CLI, we have the SDK, we have the user interface. There's a number of ways to deploy. And having multiple channels is something that, as an ISV, customers are looking to consume those products. So ultimately, there's a number of core managed components, right? Transparent provisioning and automated monitoring, managed support. These are just some of the core components required for you to deliver a solution that can obsess over your customers so that they don't have to worry about the bottom level of the stack. And what's interesting is that I think that ultimately all of these components are directly correlated to what you're trying to achieve as potentially a partner or a solution provider. And one of the things that I want to talk about is ultimately the top line item there, which is increasing your margin. As a solution provider, the number one most important thing to recognize when delivering a solution to customers is that it's a delivery and business model. And being able to obtain that increased margin through operational efficiencies and repeatable patterns in deployments and application, governance and requirements that showcase your mechanisms for delivery to your customers is super relevant. One of the things that I want to think about, and each of you to think about during the course of this session, is how can you incorporate some of these interests that you have as a solution provider and incorporate them to ensure you're obsessing over your customers. So I want to start by talking a little bit about what a conceptual view would be to help orchestrate the view of what we're going to showcase during this session. So I want to start by talking a little bit about what a functional view may look like. A functional view of the architecture design will generally incorporate a secure AWS account baseline, a multi-account design profile, one that you can provision customers across multiple instantiations of AWS, right? One in which you can go ahead and provision and maintain the security of those accounts across a wide array of regions and network topology. One in which you can deliver in a transient way, right? Way that you can deliver these workloads, these customer workloads, across n number of regions, n number of VPCs. And finally, the functional view incorporates a series of application and microservice components required for you to deliver these workloads. Now, the first question I often get when I talk about building a control plane is, well, it's interesting to talk about those core fundamental bits, but what about the platform? The platform ultimately needs to cater to my specific workflow. And I want to talk a little bit about what the kind of overall high-level platform design would look like for a customer. Because as we start to unravel the much more deep-level architecture designs, we need to understand what the expectations are for your customers. So a customer would generally sign up to your solution, and you would be responsible for registering that customer, maybe provisioning the corresponding customer or tenant profile. From there, you would register the initial user that's used to authenticate into that service. You may configure their billing profile. There's a number of billing solutions out there that partner with AWS, and there are many of those that we deliver ourselves, right? We deliver the AWS Marketplace that has the various ways to deliver a SaaS solution through a contract and through a subscription. So a user will authenticate what they're responsible for doing after they've kind of onboarded them. What you're looking for them to do is to identify what product they want, right? So you offer a number of products. They select from a catalog. Maybe they want a relational database as a service. Maybe they want an application that will allow them to deliver web application firewalls for their custom applications. And then finally, what will happen is they'll instantiate. Like you do on AWS, you create an instance. You create a workload that we deliver to you. And on the back end, this is what the customer doesn't know. They just know that there's something called a control plane that's responsible for distributing and provisioning and scheduling and maintaining and operating their workload. And then they just consume the workload. So now that you understand some of these core components, one of the things that I want to do is I want to talk a little bit more about what the profile is of these workloads. Your portfolios, you're delivering different portfolios. You're delivering maybe in a technology horizontal, right? Maybe you're a network vendor that's delivering a solution that allows for IPS, IDS as a service. Maybe you're delivering a security product like a WAF, as I mentioned, or a DevOps, or a testing, or a migration product. Your workload will vary. So the goal of today's session, depending on whether or not you're a technology horizontal or an industry vertical, is to remember that some of these concepts at the control plane level will apply. And it's hard for us to be prescriptive here in a large session about every single workload. But what we can do is talk about the repeatable mechanisms and patterns and design architecture considerations for building a control plane as it relates to more of a general purpose view. So with that said, there's a large number of considerations you would need to think about. I already mentioned multi-region and VPC design considerations. You would want to be able to provision a service catalog to identify what products you're offering, what SKUs you're offering. If it's a relational database as a service that I mentioned earlier, that's a specific SKU. And there may be a SKU based on the corresponding instance and storage types that you're providing to your customers. Ultimately, they'll need to authenticate and authorize. They'll need to be secure and compliant. The database and storage persistence options that you need to configure on your backend to maintain and distribute this workload can be complex and varied. So there's a large number of kind of approaches here across a wide array of requirements, and it's obviously impossible to cover them all today. But I want you to take a look at each of these because these are going to be some of the core ideas that you need to remember when building a solution and building that control plane to deliver for your customer. So let's talk about the 3 focus areas for today's session. We're going to talk about a multi-account region VPC network design. We're going to talk about how you provision, what are some design considerations for provisioning a workload catalog, that catalog where you go ahead and instantiate the instances, but before the instantiation, you need to give them the opportunity to select what they want. What does that catalog look like? How would the architecture look? Instance management is how you go ahead and allow them to provision an instance for their specific use cases and the state of that workflow. Finally, orchestration, deployment, and management. So We talked about this map earlier, right? And we're going to start by focusing on the secure account baseline. And what's interesting is that, like many reInvents, oftentimes we don't know when we're going to be scheduled. So I'm going to talk to you about a little bit about what we had before. And now I can talk to you a little bit about what Andy just announced as well. So we have this idea that a provider needs an environment that is ultimately secure and compliant. I have a lot of ISVs that I work with that have these regulatory authority requirements, right? They may not be able to deliver in a multi-tenant way, maybe because their customers are not willing to accomplish, like delivering, on behalf of their customers in a multi-tenant design. But ultimately, what's important is to understand that you need the ability to provision accounts in a secure and compliant way to scale and to ultimately be resilient across a wide array of components and to be adaptable and flexible, in which you can evolve your business requirements based on the corresponding design considerations for your multi-account design. So we had this solution before that was delivered, and we actually just announced a new service. And talking a little bit about some of what we've done is in AWS, we iterate and innovate based on customer needs. And we started by identifying what the core components were for being able to assess how you could deliver a secure foundation. And what we thought was, well, we need a way to provision AWS accounts through best practices. We need governance and controls to provision those. We need a starting point for net new development. You are going to be a SaaS or a solution provider that's going to iterate and innovate on behalf of your customers. In order for you to do that, your development teams and your operations teams need the ability to test and experiment, right? It's just very simplistic. And ultimately being able to start with that migration journey, because many SaaS providers have been historically delivering on premises. An environment that allows for iteration and extension over time is very important. And finally, there was at this time when we delivered this solution, before we announced the service that we just announced through the keynote, there was no additional charge for this landing zone solution. And what's interesting is what you get with it is the ability to provision multiple accounts through AWS organizations and identity and access management. And these core concepts that you're seeing here still apply through the service that was just announced. So a multi-account platform architecture design varies based on use case. And I want to talk to you about a design pattern that I evangelize and why I think it's relevant. So I want to talk to you a little bit about what we call the master account, right? Maybe many of you are familiar with the master and linked account strategy. Master account is ultimately used to be able to provision multiple n number of sub-accounts through what we call organizational units in AWS organizations. When we provision these through that solution design initially, we did it through core accounts and we did it through application accounts. And what's interesting is that when these core accounts were used for was to be able to isolate your security and governance needs to segregate based on the least privileged design best practices for AWS. You're delivering a shared service, right? If you're delivering a shared service, that could be like an Active Directory implementation or a bind server. Things that need to be shared across a wide array of n number of accounts. And being able to do that was very challenging for customers. Billing, in addition, was something that has historically standard for you being able to centralize your billing for AWS into a single account was the best practice. But to me as a solution provider, the requirements are much higher because you're no longer being billed yourself. You need to segregate the billing that you're billing for your customers. You're charging them potentially in a metering design implementation where they're paying per use. You're charging them potentially for an entitlement. And you want to make sure that what you're charging them is segregated into a different account. Network's interesting, and we'll talk a little bit more about that in some upcoming slides. So ultimately, on the right-hand side, you can see a number of application accounts. And what I want to focus on in these application accounts is primarily the service accounts. What's interesting is we have this notion of the two-pizza team methodology. I like it because I like pizza. And the idea in AWS is that you can't have a team that can feed more than 2 pizzas. If the size of the team is too large to feed 2 pizzas, then it's probably going to be inefficient. So what we do is we centralize our product teams into pizza teams. And these service accounts are used to distinguish and specify who these service teams are and what products they're delivering. Those in your implementation could be microservices. They could be products or SKUs or portfolio. Maybe there's a number of services that are interconnected that you want to deploy in a specific place. But being able to deploy these service accounts in a segmented way is crucial as you're trying to allow them to innovate and iterate quickly. I work with a large number of companies whom are very, very large enterprises. And they have these core platform components for their SaaS solutions in which they're trying to be able to deliver n number of products very quickly. So they spin up platform teams. These platform teams build authentication, the authorization, the policies, the billing. But then the challenge is that because they've consolidated all in one account design pattern, it's very challenging for them to enhance and allow their customers to innovate. So those service accounts are a great way for you to be able to go ahead and segment your customers accordingly. I'll leave this slide here a little bit for you if you want to take pictures. But ultimately, this best practice can be implemented based on your design patterns. And it's just kind of an example to demonstrate why you would want to do things a certain way. So the landing zone structure is a little different because you now heard of our new service that we released. And I want to talk a little bit about the network design. And the reason why I want to talk about the network design is because, to me, fundamentally, if you don't have a wide distributed network that allows you to distribute workloads, if they're a relational database per customer, then you don't have a global delivery mechanism to deliver these workloads. So this is crucial. And I'm going to start by talking a little bit about some of the considerations, because to me, it's easy for me to show a reference design, but that reference design often doesn't fit every use case and every company and organization. The goal here today is to demonstrate why things matter and how you can take those considerations and incorporate them. So you would want a global network connectivity to manage this wide array, from a provider perspective for you to manage them, but you would also want regional fault tolerance. And the reason why this matters is because in AWS, when one region goes down, there's no catastrophic failure resulting in another region to go down. So you need regional isolation. You need a centralized hub, potentially, for ingress traffic so that you can gate who's doing what and ensure that when that traffic is going in, that would be regionalized, obviously. But the idea here is that if you're delivering multi-tenant platform services, single or multi-tenant workloads to customers, it's crucial that you have the way to be able to identify maybe potential malicious activity and block it at your entry points. You would want transitive-like peering. And what's interesting is historically in the past, we've had VPC peering and other services that we'll talk a little bit more about, but transitive peering was a very challenging thing. And we'll talk about why that's important, but it allows you to be able to, as an example, instead of going from A directly to C, we didn't have transitive peering in our VPC peering communications, where you'd have to peer in what we call a full mesh. And that was challenging for customers. And we're going to talk about design patterns here later as to how you could solve those problems. Customers may have workloads deployed in multiple regions, accounts, and VPCs. And what's interesting about these is that I really think that it's important to think about the connectivity options based on the workload type. And I'm going to describe that in significant detail because it's crucial to understand that you may be allowing them to communicate to your web services for your SDK, your CLI, and n number of services through a public web service. But as to how they communicate to the core workload itself, if it's a database, being able to expose that is not acceptable necessarily for a customer. So understanding the design patterns are crucial here. And finally, workload connectivity setup. Being able to understand how to automate your workload provisioning is crucial here, right? So one of the design patterns that I often hear from customers that are deploying solutions as a service on AWS is, what's the challenge that we have is we got like 10 products we got to ship by the end of the year. We got 12 months to do that. And the challenge that we have is that each one of these components is so different. And I'm like, well, can you get to that lowest common denominator? Can you identify what the key patterns are for you to be able to initially, through that MVP, get an 80% connectivity setup so that you can enable your customers based on the 80%, not by those 20% outliers? And we'll explain a little bit more about what that means. So multi-region network requirements. So ultimately, we talked a little bit about this, but this is a very simplistic chart. And I like simple because we have this idea of invent and simplify. So you're delivering a service that may be across regions. You may deliver, similar to what we offer in multi-region tables with DynamoDB, a service that will require you to be able to peer multiple regions together. But those customers may have workloads And those customers, before I get there, their customers may be deployed in either single or multi-tenant VPCs. And I'll explain to those that may not understand single versus multi-tenancy so that you understand this concept a little bit more. Single tenant is when you deliver an infrastructure and application per customer, and you're deploying that either in a single implementation of that infrastructure or in a single instance of that app. Multi-tenant is where you distribute multiple customers to obtain those operational and cost efficiencies. Many of you know that when you're doing a shared deployment model of EC2, you're doing multi-tenancy. We recently announced Firecracker, which is now our micro VM capable a KVM supported virtualization technique that's been open sourced, and that supports multi-tenancy. The core tenet here is that understanding that your customer cost profile and implementation model will vary. Why would I want to do single versus multi-tenant? Well, multi-tenant allows you to obtain those cost and operational boundaries that you need to remain a high margin business as a solution provider. Why would you want to do single tenant? Well, because your customer may need those compliance and regulatory requirements that only come potentially with single tenancy. And those customers likely will have to pay more. So you deploy these workloads. And as you can see over here, I'm going to see if I can get this little thing to show up. I don't know if it sort of like a... So you can see right here that we have application 1, and down here we have application 1. So customer 1 has application 1, and that same application is in another region. So what are the requirements again? Well, the requirements are that if these two fail, that one still needs to work. Well, how do you do that? There's a number of technical challenges, and from a network design is what we're going to focus on in the next couple slides. So I want to introduce you to a couple concepts that you may already be familiar with, but I want to kind of balance out the pros and cons. And I'm going to talk to you about a service that I couldn't put in this deck because I didn't know when I was going to present. But we announced something earlier this week, and I'll talk a lot about that. So VPC peering. VPC peering, we mentioned this kind of notion of peering in a full mesh, where you have to peer from VPC A to VPC B, from VPC A to VPC C, and VPC B to VPC C. You can't go directly through one of them, right? You have to peer them all. And we'll talk about why that's good and why that's bad. Transit VPC is this kind of implementation model where you could actually have what we call a hub and spoke. So all of your ingress potentially may go through into here, and then you're routing that through potentially a third-party solution, potentially like a Cisco CSR implementation that we have. It could be a router in the cloud that allows you to make a secure connection. Now, the challenge is that hub and spoke model requires what we call a VPN. And many of you know that in a VPN model, there's a number of constraints. VPNs historically are limited by 1.25 gigabits per second in egress traffic. So you're trying to go from here to here. There's going to be some constraints in that bandwidth connectivity. And we'll talk a little bit more about that as well. And then there's this solution that we released last year called Private Link. Private Link's a great solution for enabling your customers. It's also used as a design pattern to allow you to be able to deliver a multiple account strategy for yourselves. If you're delivering if you're delivering a VPC per tenant, and you're instantiating that VPC per tenant. In this model, just at a technical design consideration, what happens is each availability zone will have an IP, and the traffic will route out that IP to what we call a network load balancer. That network load balancer is a layer 4 load balancer that allows for a high amount of throughput. And what's great to know is that network load balancer gives you the ability to terminate through any number of applications behind that layer 4. It provides a very strong backbone to deliver workloads. But again, the challenge there is that you're delivering out each AZ, and you have to have an endpoint, which may be a DNS record, surfaced as an example to send those traffic accordingly. So as an example, one of the implementation approaches that you would have here would be that maybe you're leveraging a marketplace product as a customer. Imagine as a moment that you decide to spin up a product, a partner that we greatly respect, which is Sumo Logic. You're leveraging their log ingestion platform. How would you consume Private Link if you're trying to go to them? The way that you would do that is they have Private Link enabled on their applications, and then you would enable an endpoint where it could route out multiple AZs directly through a low latency, high throughput connection internal to the AWS network. So these go out the internet. This does not. So there's a value proposition here, but again, looking at some of the constraints here, we can take a look at some of the benefits and the pros and the cons. So he talks about bidirectional capabilities in VPC peering, but that ultimately requires you to be able to have a full mesh. And one of the challenges here are there's a limited number of peers supported. Another problem here is it's going to become a nightmare to manage when you have hundreds of peering connections. There's a limited number of peers, there's no transit peering, and of course it's AWS only. Transit VPC enables that because now you could do this like implementation across a large array of different kind of potential on-premise and hybrid implementations across cloud, across customers. It allows you to network and segment multiple accounts in your multi-account landing zone implementation. But again, there's lower performance. I talked about that 1.25 gig, and it's again very complex to manage. Private link has a number of positives, but again, it's limited based on AWS only. So I'm going to stop here and talk about something that I don't have a slide for because I didn't know when I was going to present, which is a service that we announced called AWS Transit Gateway. The Transit Gateway allows you to peer a large number, thousands of VPCs across region, across customers to yourselves. So you can have hundreds of VPCs that you're maintaining across multiple regions to deliver to your customers, right? And those you need to centrally manage. But in addition to that, you may want to peer to them. Why? Because you're delivering a single tenant workload, maybe a database workload, and you want to deliver that database workload in a secure network connectivity way. How can you do that? Well, you can enable them to enhance through an endpoint on Transit Gateway for them to peer accordingly. So it's a very, very flexible way to be able to enable your customers. I wish I had a slide for it, but unfortunately, I didn't know when they were going to announce it. So let's talk about some global connectivity options. So one of the things to think about is, Transit Gateway allows you to enable globally. But there's a number of other services as you're trying to extend through on-premises environments as well. And Direct Connect, if you're using Direct Connect, it's a service that allows you to deliver you 1 or 10 gig secure private connections between your on-premises data center and AWS. And there's network providers and partners that we have that will enable you to do different types of bandwidth accordingly. Direct Connect Gateway allows you to do regional connectivity to enable multiple regions in AWS down to your data center. The challenge here, though, is that it requires a data center, right? And the goal of this topic is to talk about how do I enable that control plane exclusively in AWS. But important to know if you're delivering a solution across your on-premises facilities as well as AWS. Inter-region peering is another one. Again, it has many of the constraints that you'll find in VPC peering, but inter-region peering will allow native connectivity. There's no management required, but again, you have that full mesh necessity. Finally, cross-region VPN. Cross-region VPN allows for transit VPC consistency because you can use the transit network. It's full control of connectivity, and that minus should be down below. It supports overlapping CIDR blocks. Imagine how important it is if your customer has a 10.1.0.0/16, and one of your subnets has that, and you're trying to route a request from that customer to you, or vice versa, right, based on the type of solution that you're delivering. If you don't have overlapping CIDR block, that could cause a potential challenge in you delivering your businesses. So there's a number of other options for on-premises. You can have VPN. We talked about some of those problems, 1.25 gig. Management's a nightmare. VPN over AWS Direct Connect is a great option if you're using Direct Connect to allow you to enable customers through your on-premises if you want to route directly through your on-premises environment, and a detached VGW. So these are some of the options. I'm not going to go into these too much detail. But initially, before we announced Transit Gateway, I had this idea of, well, why would I want to use the transit VPC implementation for my design? Right? I'm trying to deliver customer workloads in a general purpose way that will allow me to deliver these workloads in a way that will scale. Now, the challenge, though, is today I have a large number of workloads that are delivered in overlapping CIDR blocks. I have challenges because I need that capabilities. I have challenges because I need the ability to route and traffic inspect, and I need to be able to manage security. So the Transit VPC hub would allow me to deploy in 2 availability zones, getting that redundancy. It supported VRF to allow me to support overlapping CIDR and double NAT. And it also allowed me to support duplicate tunnel addresses. But now what's interesting is with Transit Gateway, you can do a large number of peering across thousands of VPCs with a new managed service that doesn't require you to use one of the services to enable your transit VPC implementation. And if we take a look here, we talked about the requirement. The requirement was we want regional isolation, and if that fails, that region fails, this one will still be available. And using transit VPC implementation, I was allowed to be able to obtain that. But now with Transit Gateway, the new service that we announced and released, what we can do is we can peer them globally together, and we still have that high availability. And one of the features that Transit Gateway supports, besides thousands of VPCs, is a significant amount of throughput, which you can't necessarily get today with a Transit VPC implementation. This is a great design pattern for one approach. Potentially, if you need overlapping CIDR block today, this is the design pattern that you would take. If you don't need overlapping CIDR block, I really evangelize and recommend you take a look at our new service of Transit Gateway. So moving forward, I want to talk about some of the Transit VPC ecosystem, because it's important for me to evangelize a number of the partners out here that enable Transit VPC. But I think it's also just as important for you to take a look at your core business requirements and determine if you can enable your customers in a turnkey way and your own AWS accounts in a global fashion through AWS Transit Gateway. So we talked about the design patterns that you would want to regionally and deliberately connect multiple VPCs in your account to instantiate and maintain the workloads for your customers, right? We talked about ways for you to deliver those customer workloads and maintain them. We didn't talk about the application components because them are coming shortly. But now your customer needs to communicate and connect to that workload. We talked about relational database as a service as one use case. So if you allow your customer to connect through a security group, then that's potentially an anti-pattern. It's unidirectional and allows you to be able to communicate potentially through a load balancer or direct through potentially through the IGW, allowing you to communicate directly to that external IP address for that instance. But there's a number of constraints there because ultimately it's a security anti-pattern. VPN, unidirectional. Peering, unidirectional. Peering allows you to do it and manage it through AWS CloudFormation. There's ways for you to enable yourselves to reduce friction for your customers. And the reason why peering, to me, is a great way to enable your customer is because your customer is looking to get up to market and get up to value as quickly as possible. And peering is a great way of doing that. Now, private link, we talked about the NLB termination. The reason why this is relevant, again, is because private link termination at the NLB ultimately constrains you to some extent because you have to terminate at a load balancer. What if you need client-side discovery? You have maybe a NoSQL database that you're offering as a service, right? And that NoSQL database as a service, you're delivering in such a way where you need to do client-side discovery of a number of IPs. Private link won't allow you to do that unless you're just doing maybe to a large number of read replicas, right? You would have to maybe terminate through an NLB for read replication to be able to do a large number of reads for read replicas. But that's not sufficient if you need to be able to actually reach out to those IPs directly. Transit Gateway, again, allows you to enable your customers through a secure NACL that you can control. So the NACL is an internal private NACL through AWS global network that you can maintain and control. So it's unidirectional, and it allows you to make sure that your customers are enabled just like you are in your back end. So you have consistent throughput, you have consistent traffic, and again, you have a consistent way of delivery. So we talked about the network design. There's a number of different things we can go into there. It's a pretty significant deep dive, but one of the big pieces that I wanted to cover today is the application. I am a solutions architect who focuses significantly on software development. My exclusive role, to some extent, is to enable these solution providers to build the applications that are required for them to put on top of this network backbone. And I want to talk about the client perspective of a control plane, because we see things on the external side, and it's much more simple. And what I want to do is start there, because many of you may not be familiar with what maybe a control plane looks like. Starting there will give me the ability at a technical level to get you then to that next deep level. So a client interaction ultimately results from a request. That request comes from the API, the CLI, the SDK, whatever the case may be. The customer would ultimately say, hey, I want to view a catalog, right? Or I would want to, or if the catalog is not a direct API, they would just say, I go directly to a specific product portfolio that I have for an SDK released for. And I would instantiate, I'd maybe create or update or delete that instance. That instance may be, again, a relational database. It may be a healthcare application that you're delivering, maybe a number of healthcare applications. It may be a FinServ solution. Ultimately, what they're trying to do is be able to instantiate And after they instantiate, you're responsible for being able to maintain the provisioning and the release profile and being able to tell them, okay, you're ready to consume, or you're not ready to consume. Super simplistic, and now we're going to deep dive in a moment when people finish taking pictures. So, simple perception of a control plane. Let's dive in a little bit deeper. There's a large number of components. Even if you were to deliver a control plane in a very minuscule way, you're going to need a large number of multi-tenant potential microservices. So I want to show you the ones that maybe we could talk a little bit about. I want to show you some of the ones that we're not going to talk about. But what I want to do is I want to create a conversation. I'm not going to be having time to take questions during this session. But at the end of the session, I'll be available outside the room to answer your questions about this in a very, very deep way as it relates to your prescriptive guidance. And I'll give you some stickers. So let's think about the client interaction. You obviously need a client. You need a public API. You need an SDK. You would also need a distant administrative GUI. You would need a distant private API for the corresponding API interactions that you have for each microservice. Some of the public APIs that I'm listing out here are some of the minimum requirements to me if you were to implement this in a turnkey fashion for customers. So you need the catalog. The catalog is that product catalog with the SKUs. They say, hey, show me what services that you have, right? You're going to showcase that through the user interface. Likely, they're not going to go ahead and search your product catalog API. They're going to go through the interface and say, OK, drop down, I see what products there are. The instance service is the one per core workload that you're delivering. So I'm calling it instance here today because I'm specifying that you only have one workload type. Imagine that relational database is one SKU. That would be one instance. Maybe now you offer a different workload. Maybe you offer a application platform as a service solution that has a different SKU. That would be a different instance service, right? But many of the other collateral aspects that are related to it on the right-hand side would still be consistent. And the reason is because you're trying to innovate and iterate quickly. Your goal is to get these customers to market. In order to get them to market, you want these core platforms to be consistent across multiple instances, instance per product. Finally, we have administrative services. So we need to monitor and the specific provisioning of that workload. We need to monitor the workload itself. We need to make sure that we have some back-end maintenance and management to ensure that here we're managing that workload where we're not exposing data back to the customer, right? There are back-end things that we need to know as the ISV, as the solution provider. We have to know catalog management. We have to update when we decide we want to change our product catalog or our pricing. We need also, again, a very simplistic notification service. These are the core control plane components. Now, the first thing I often hear is, well, wait a minute, you're missing like a whole bunch of microservices. What's going on? So these are the ones I'm not even going to scratch today. There's obviously a large number of services that you need. You need a tenant-based service. You need a authentication, a single sign-in, an API key service. You need a token exchange service because you're trying to authenticate a user via SAML 2.0. You're trying to get their JWT token to convert from an OpenID login, right? Their OpenID profile allows them to log in through a user and a password that you're providing to them, right? Maybe you're using a provider such as Cognito User Pools, right? And you're trying to authenticate them, allow them to use the application. Well, you need a way to centralize all of those users into a single identity that you maintain as the provider. So these are core components that are crucial. Users, groups, policies. You need to manage the security. Roles are very, very crucial. But what's interesting is that we have this new paradigm that we see as we work with our ISVs. We're seeing that role-based access control is changing. You all use AWS Identity and Access Management. You see how it works. Identity and Access Management works through a policy defined in a JSON document. That JSON document defines what you can do for what resource, right? So you have a resource, you have a method, potentially it's a DynamoDB colon put item. Maybe it's a s3.get or batch get. Whatever the case may be, you would want to define a policy management system that will work for you. Because as you're delivering hundreds or tens of products, you need to make sure you're getting to that level of scale. There's a large number of other products. Billing is crucial. And what's interesting is that it's often a pitfall of ISVs to build their own billing system. Billing is not something that's easy for a technology company to own unless that's their core competency. And the reason is, we'll talk about some of the ways and the challenges that you have to use when building a billing system in a session later today that I'm giving. The session is migrating single-tenant to multi-tenant applications. That's not the core scope of today's session, but it's crucial to understand that billing may not necessarily be something that you would want to build, but you may want to integrate through metering and design patterns here. These are operational requirements here that are crucial to being able to deliver a control plane and a solution. So we talked about some of these components. I'm not going to go into the right-hand side of administrative services, but the idea is likely if you're building a solution provider, scalable real-world mechanism, at the minimum you need, we're talking like 20 microservices at a minimum. Building these as microservices allows you to be able to extend and scale your business. So let's talk about an architecture that potentially will allow you to instantiate resources for a customer. This is a reference pattern, not one that's used necessarily for your solution. It's used to demonstrate and illustrate some of the resource concepts that we described before and some of the provisioning requirements that we discussed, so you understand how to take those considerations and bring them into reality. So you would have a number of tenants with ultimately multiple users. These tenants are your customers. You have 3 customers in this scenario. These customers are going to go ahead and hit maybe a web client or directly through an API. They'll authenticate maybe through an API key or through a Cognito user profile, user name, password. What will happen is that they're going to ultimately hit some type of API. In my illustration, I've showcased Amazon's API gateway. It allows you to hit any number of RESTful services, right? It allows you to now do WebSockets as well, which allows you to be able to connect to any number of different types of communication profiles for you to enable a number of microservices. The best practice here that I often see as a pitfall that I want to make sure to illustrate is that there should be one API gateway instantiation per microservice. And the question I ask is, I get often is, why wouldn't I want to do multiple instances behind an API gateway? And the reason is because you would want to throttle each service differently. You would want to meter each service differently. You'd want to be able to authenticate each service differently. Potentially, maybe as you're versioning your APIs, you're going to be able to identify challenges through the API provisioning and being able to have stages through dev, potentially straight QA and production for each API gateway implementation per microservice allows you to mitigate the potential challenges for having that, again, monolithic design. API gateway per design is a best practice. We have this notion of what we call a Lambda authorizer, and just to introduce this concept to customers and to partners, the Lambda authorizer allows you to take potentially that token or a third-party token, maybe an OAuth token or a user profile, and build a Lambda function that could allow you to authorize the user in a tenant for specific access to those API endpoints. Cognito now also supports what we call OAuth 2.0 scopes, which is very interesting. And there's a number of our solutions architects in the SaaS Factory team that are giving sessions at a deep dive here. If you want more interesting information about it, please reach to me after the session. So now the way that I've instantiated this is, what is an instance or a catalog service? A catalog service is the product SKUs. I need a series of product SKUs, and that's a pretty simplistic database. It's just a create, read, update, delete database. So in my implementation, what I've done is I've created a Lambda function using AWS Lambda and Express JS through Node. And then I've gone ahead and persisted through Dynamo. What's interesting is, though, in my implementation, I would want to make sure that I'm gating access to who could view the catalog, because I may want to demonstrate and illustrate the private pricing. One of the challenges with exposing your pricing in a public way, it's great for marketing to non-customers, but oftentimes it's deceiving to existing customers. When you have an enterprise discount program, it's very important for you to showcase your pricing. And the way that I do that is I have the ability to manage that catalog API and instantiate the records in that API in a multi-tenant way to showcase you as a customer that for this product, your price is different. Very crucial as you deliver your solution. And I have another API gateway implementation just for an instance service, which allows me to instantiate a resource. So far, this is relatively straightforward. The idea is now at this state in the game, I have the ability for a customer to go ahead and say, I want to look at a product through maybe a user interface, that's maybe an AngularJS or a React Native client in an S3 bucket. And now what I can do is go ahead and allow them to view that product, say, hey, I decided I want that one, and then create an instance of that product through whatever that instance API would be called based on your corresponding product SKU. But now I want to take it one step further. It's important to recognize that the control plane is much more sophisticated. So in this circumstance, what I have is a request that actually should be coming out from here to there, where I'm actually creating a kinesis record. This kinesis record, it looks like that, there's a little bit of a typo there on the diagram, but the idea is that the Lambda function is going to instantiate a request to the kinesis stream and say, this is the request that I want the control plane to provision for the customer. What do I want? I want a CRM application to be provisioned. I want a load testing suite to be provisioned. I want a NoSQL database. I want a machine learning algorithm deployed. Whatever the case may be, whatever you're delivering to your customer, that's going to be the request. They're going to make the request saying, I want X with corresponding config, and you push that out directly to a stream. From here, what we have is the next step in the architecture. So you have a Kinesis data stream. Kinesis allows you to do a large amount of ingestion of data. It allows you to import a significant amount of records that are less than 1 meg in a similar way to what you'd find with Apache Kafka. It allows you to be able to ingest these records in near real time and process these records for telemetry, for analytics, for provisioning. So I have a Lambda function called instance administration. Remember when I talked a little bit about this idea that you don't want to expose to your customers what's happening on the back end? Well, my instance administration service is going to be responsible for me to get all of those private APIs. So if I go back one step to the last slide, you're going to see that the blue indicates, for me, my public kind of services. Now, this is obviously not public. It's controlled by my private IAM roles that I have as managing. But the idea is that here, these are public APIs. On the next slide, I now have purple to indicate that these are services that are back-end services that are responsible for provisioning and maintaining the core aspect of that control plane. So how many of you have heard DynamoDB streams? It allows you to ingest a large amount of records in near real time through what we call events. And pulling off these events at one at a time through the course of state transitions is crucial for you to monitor the state of your workload. So imagine for a moment, and I'm error prone as a customer, what I'll do is sometimes I'll go into AWS and I'll say, hey, I want an RDS. And I'm like, oh shit, I need a different instance type. So what I'll do is I'll try to maybe change that workload, or you would want a way to pull that DynamoDB stream. You would want a way to make sure that the customer has maybe a couple seconds between that, and maybe there's ways for you to be able to maintain that. Now, creating something may be different. It's more challenging to maintain a creation state. But a modification state is something that's actually even more crucial, because creating something doesn't result potentially in production downtime, but modifications do. And that's why DynamoDB streams and pulling DynamoDB streams allows you to be able to maybe for a few seconds after pull and say, hey, okay, was there any other events that this customer instantiated on that specific resource? Maybe I need to make sure I only take the latest and greatest. So a state machine trigger. So Lambda, what's interesting is that you can have a Lambda subscribe potentially to DynamoDB events. And what's great about that is that this trigger is going to pull those events, and then it's going to instantiate a step functions workflow. Step Functions is a new service that we launched last year at reInvent. It's a service that allows you to build a state machine, a business process workflow that retains and remains through state transitions, some that can happen concurrently, some that can happen one after the next, some that have choices, ones that will bring out the challenges that you would find in a true provisioning pipeline. And what's interesting is that through the course of my architecture design, most of my control plane I've decided to include in AWS Step Functions. And the reason is because likely what's going to happen is in order for me to provision and maintain a customer instance in a way that's repeatable pattern for n number of workload types, I need to find a way to have segmented functions or purposeful functions based on each workflow. And I may have one workflow that repurposes much of what I've already had in an additional workflow. So now I have one workflow in a step functions business logic that allows me to be able to instantiate a database workload. Another similar one with some minor modifications in a different state machine that allows me to manage a different workload. What other workload would it be? Maybe it's an object store. Maybe it's a network file system. Maybe it's some type of network traffic management solution. Whatever the case is, whatever the workload may be, using step functions allows me to be, number one, flexible, Number 2, reliable. Number 3, repeatable. And repeatable to me is crucial because the goal of this session is to describe to each of you as a solution provider how you obtain that scale as a business. Modular design allows you to be able to obtain those operational efficiencies and increase your margin. And that's crucial here. So just like every other large-scale ISV solution, one of the things that you would want to do is you would need a configuration that would be specific to the instance where you specify that every instance or workload that's X type of workload would need some specific type of enrichment data that's used to provision it through the process. So my control plane through any number of Lambda functions, or it could be pulling, maybe pushing and executing through Docker containers, right? That state machine through step functions will go ahead and pull my configuration for that type of SKU and pull that information also similarly from a global configuration. Now, one of the big things that I want to ask each of you is, why would I use a global configuration service? What's the value proposition here? My value proposition specifically is because I want to release products per region based on my rollout schedule. So AWS releases services to you, to each of you, in different regions based on when we get compliance, regulatory requirements based on region, when we meet the sovereignty necessities of that corresponding country, whatever the case may be, we're only going to deliver certain products in certain countries or in certain regions. So you need a way to identify where it's allowed to be deployed and how it's allowed to be deployed on the back end. So through the course of me going ahead and provisioning this workload through the control plane, which we'll talk a little bit more in a subsequent slide about how that works, ultimately my workload will either get created, maybe fail through provisioning, maybe I'm provisioning it through CloudFormation, maybe I'm provisioning it through Terraform, maybe I'm doing an aggregation of Terraform, CloudFormation, custom code, Fugue, which is a great partner solution for provisioning. Maybe it's a galvanization of a Helm chart, a CloudFormation template, a Terraform template, an N number of different kind of OpsWorks integrations. My workload will vary, but because I have that ability to maintain state and to provision things based on the corresponding workload of my state machine, all of my other microservices remain consistent through all of my portfolio of products. So I send the notification to a user saying it's done. Or potentially I send an application notification through SNS through that notification service that notifies the application client. One of the big things that I like, because I'm lazy, is I like to see when something's done. I don't like to wait and be like, refresh, refresh, refresh. It's not a great user experience. And what's great about SNS is it allows you to notify an HTTP endpoint. So you could have a poller of that HTTP endpoint, which will ultimately invoke a client call, allowing you to be able to notify your customer as soon as they click that in the user interface. Now, you also need some other way to manage notifications. Some workloads that you may be familiar with may email the user, hey, it's done. The great thing about SNS that allows you to do text messaging, it allows you to do HTTP endpoints, and it allows you to do a very numbered of different kind of approaches to notify the user. Okay, so we talked about now the provisioning piece of it, but there's one piece missing. The piece that's missing is that we need to monitor and learn from the reactions of our customers. Our customers are having challenges because maybe initially when we launch the service, we don't really know like the user experience, right? And we need to obtain that telemetry. So one of the ways that we can do that is we can expose analytics through our administration service or through our corresponding control plane state machine. And now do Java. This is a new feature that we released earlier this week, which is you can do Java real-time analytics through Kinesis Analytics. And real-time analytics is important as you're trying to visualize things through maybe a user interface, potentially like QuickSight or maybe like a Tableau solution. It's crucial. So being able to provide custom Java applications to do that real-time analytics is important. Kinesis Firehose is also crucial. And the reason why that's crucial is because many of you want to be able to monitor and maintain the life cycle of your customers and the profile of those customers and the analytics strategies that are required. So what I have done is in my architecture, in my reference solution, I've decided to have Firehose pull from Kinesis Analytics, ingest that data for batch analytics into S3, I have Glue, which is our ETL transformation service. It's going to pull from that S3 bucket, and it's going to allow me to do what we call a Spark application. So those familiar with Spark know that it's about 10 times more powerful than some of the historical languages that you've found in the big data and machine learning space. And what I want to do is I want to be able to segregate and segment my customer, my tenants, in the Glue. And I can do that through a number of different ways. Glue enables you to segment customers into different catalogs. And that's crucial for multi-tenancy. And finally, I've decided to put Spark MLlib because I want to learn from my mistakes. I want to know what I've been doing right and what I've been doing wrong, but I want to go to sleep. I don't want to do any of this. I just want to set up the architecture and go home. And tomorrow morning, when I view that visualization, I know exactly what happened, and I now can learn. And my EMRFS cluster may have a Spark application that's invoked, maybe in a Lambda function. This doesn't really matter how it's done, which will ultimately be responsible for maintaining and changing the workflow so that it's more optimal and it's more scalable. So what I have is a flywheel. This notion of a flywheel is important. You want to leverage machine learning. You want to leverage provisioning in a way that you don't have to do much other than set up that initial design. So ultimately, we're missing a core component of the architecture, and I'm almost through the architecture design patterns here. We have to support the administrative flow. We have to support the ISV who's maintaining these workloads for your customers. So I have an admin client. I may have a similar approach here. And that admin client is ultimately what it's doing is I just have a catalog manager to maintain my catalogs. Pretty straightforward. And then here is interesting is I also, and I see this design pattern actually more frequently today, is I need an approach to use what we call Amazon state language, which is what we power Amazon step functions, AWS step functions with, which allows me to power those business process workflows that I was talking about. But I need a way to expose that to my internal development and ISV team. And the reason is because they're going to create a new product. That product team says, I want to invoke and provision that new product SKU, and I need a new workflow to enable me to do so. So you surface your API to do so. So we talked a lot about now the architecture design. I'm going to move forward and talk about the business process flow that I designed for step functions, and talk to you a little bit more about how step functions enabled my control plane. So I'm not going to walk through each of these steps, but you can take a picture. There's a number of reference patterns and solutions online on GitHub that you can find that showcase ways for each of you to provision and maintain instances and workloads and CloudFormation templates to be able to maintain these delivery mechanisms at scale. And one of the ones that you can find online, which is great, allows you to be able to source from a GitHub repository a series of pieces of Amazon's state language, right, and a number of CloudFormations, and to provision those as soon as you commit. So you're going to update your CloudFormation templates as soon as you go ahead and push. So now you have an automated infrastructure as code pipeline integrated with your DevOps CI and CD strategy. And it's a great thing that's out there on GitHub. And if you just Google code pipeline, GitHub, step functions, you'll find that great resource. So I talked a little bit about the business process flow. I don't want to focus too much on it because ultimately it will vary based on your use case. And it'll vary based on product SKU. But I want to talk about step functions. So here's an example of a state machine that I've defined in a JSON syntax. Now it's a much bigger document than this, and it's impossible to get the large document on the slide. But what I want to outline here for you is that this is the task. So right here's the task, input param is valid. So to me, I'm saying, hey, there's a choice here. Based on what the output is from maybe the previous function, right? Or based on the output from this function, I decide where it should go next. And that's crucial to me because if the instance provisioning of that relational database fails, what am I going to do? I don't want to tell the customer it failed. I want auto heal. I want to make sure that that workload gets up and running. Because if I don't get that workload up and running, time to value is lost, time to consumption is lost. And if they're paying per use for that workload, well, then there's a challenge because I'm losing money. So that workload, using those choices and using those state machine transitions as a business process flow is very optimal. And as you could see here, this is kind of how it's not mentioned for you to necessarily read the corresponding states that you saw before. But this is kind of a view that step functions enables you to see. So you can see that what I'm doing is I'm first checking the input parameters that are passing because I never hard code anything. It's all params that are passing through my Lambda functions. I've checked the parameters for that DynamoDB stream based on the corresponding key value pairs that are in that document. And then it goes through this different state changes to be able to ultimately, after the instance is updated, created, or deleted, or maintained, that it's all done for me in a frictionless way. So with that said, I want to tell you all that I really believe it's important, if you are a solution provider, to build a control plane. If you're not a solution provider and you're a customer, or if you're not a solution provider and you're a consulting partner, is it not just as important for you to make sure that you're delivering to your business units in a frictionless way? Is it not as important for you to make sure that there's repeatable patterns, that you could save money for your business? I think it's just as important. But it's crucial for a solution as a service. So things to remember: try to build that secure foundation. Take a look at our new solution that we delivered for building that secure solution. It's called Control Tower. Control Tower allows you to be able to do that AWS landing zone implementation that we discussed before, which Andy mentioned earlier today. Try to assess the business requirements of the network and potentially consider either a transit VPC with a VPC peering for inter-region peering, or do maybe a transit gateway implementation, or don't do any of those, but do one that works. Maybe do potentially a direct connect gateway that allows you to do multiple region peering. But if you want to deliver the business requirements to deliver those customer workloads across multiple regions. Define the process flow. This is a business process workflow. This is a business function. Whiteboard it out. Don't just go execute and build it in whatever tooling that you're doing. Write it out. Say, what am I trying to accomplish? And piece by piece, what is the architecture design? And finally, evaluate the customer's method of that interaction. So I'm going to go back for you to take a picture. So finally, I want to close with, if you streamline your customer workflow, it's going to ultimately result in a customer success. A customer success is this generic metric that we use to ensure success through an organization. It'll give you the ability to develop reusable components, improve your operational efficiencies, and finally ensure customer success. And that customer success is crucial to you closing and ensuring that you don't have that churn for a customer. So I thank you so much, and I want to introduce the SaaS Factory program. It's a program that we have that helps provide repeatable patterns on building multi-tenant workloads. Take a look at our content here on the website. Please attend our sessions here at reInvent. If you want a sticker, come talk to me after. If you don't want a sticker, don't come talk to me after. But if you want a sticker and you don't want to talk to me after, I'll still give you a sticker. Thank you so much, and it's great to meet you all here at reInvent. Thank you.